So we're going to jump in. We're going to be doing some stock price predictions. We're going to be using the burn library in Rust because Rust for everything, Rust for all of it. I think it's a good, I'm kind of excited because I've been using PyTorch for a little while. I like it. I like the simplicity of it. Let's jump into where we're at now. And then we will be done here. This is where we're at so far. We've got our backend, which is running on Mac. So it's Metal backend, whether you're running, Apple Silicon or whatever video card you have installed in your system. And then we've got a couple of neural network layers, right? We've got some layers. Are we using this layer config? What are we doing here? Oh, to instantiate a new layer. Oh, that's neat. All right, there we go. We're learning some new things here. Isn't that neat? I think it's pretty neat. We got so we probably don't need more than one activation layer. Is that right? I guess we don't really need to create multiple ReLU layers, right? Based on this docs here, it shows that you only need one. So you could just do another self.forward here. We only need to define it once. So activation could just be this, right? Although, I suppose, where would we, I don't know. We'll keep it like that for now. Okay, so we need to do this part here. Let's do this part here. We'll do linear one, forward. Okay, get rid of that. We don't need that. We're not using dropout. We're not using that. We are using activation though. And the activation is 1. All right, so we'll do that. And then we want to do that again. So that way that pops up as the same both cases as in our model here. And it looks like our output here, linear 3. Okay, so we'll add that as well. Here we go. To increase increment by 1. Thank you. Okay. And then we don't need any of these things. None of those things are there. We don't need that either. All right. Oh, wait. We need to return the last thing here. So we just return X, basically, is the idea. That's what we got to do. Here we go. This is it right here. This is what we want. All right, we found it. Thank goodness. All right, here we go. Copy. Let's paste this in over here. All right. And then we need, was also, instead of web GPU, we need metal. I believe it was metal. All right, let's see. Cargo LS, hold on. Cargo build. Cargo build. Is it going to build? Did we do it right? Did we get it all back? Invite B2, all right. You just returned the wrong super. Is that what it was? Is that all it is? So it needs to be a different super. So instead of 1, it should be 2. Expected, found. Oh, so it's got this. It's returning this, which is a linear. What is that return? So whatever this returns, that's what that is. So is it just a B, like that? All right, let's try that. It's better. We made one step closer. It's type Nevoke. Nevoke. All right. Thank you. Help me out, Nevoke. Don't go away. Stay here. B for block. Block us. How's it going? Block us. All right. So, D. All right. I don't know. D. Really? I don't know. See, this is weird. It's like, see, it does like it always does this. Like, add this into the thing. Oh, okay. All right. How do we do this? Is it comma 2? All right. We'll try it. We'll try this. We're just messing around. If you guys know, is it all of a sudden good? Is it all of a sudden good? Wait, no way. Hey, Quantified Malcolm, you're back. All right. You came back at a good time because it seems like we kind of brought back all the code I deleted accidentally. Oh, there it goes. Okay, it finished. All right. I don't know what that did. I really don't. I don't know Rust. I'm just a Python guy. Me mostly too from Python in an artificial intelligence perspective. Can you pause on the error message a bit so we can read it? Okay, cool. Hey, it's gone now. It's gone. You can't see it because we fixed it somehow. I don't know how we fixed it. I really don't know how we fixed it. We just started messing with it until it worked. So I guess we'll find out. All right, so forward, X forward. All right, so I'm guessing what we need to do is we need to actually use this now. So in the main. All right, so we've defined the model. All right, so then can we do model.forward? Is that what we do? So what happened there was just types. It was just types. Okay. The compiler couldn't figure them out for you. That's it. Yep, that's one of the great things about the Rust programming language and the compiler is that it is very strict, and it will do its best to help you out. And it kind of does a little bit, but it won't make sense a lot of the time. It won't go run. Let's make sure it runs without blowing up. It worked. All right, look at that. All right, input and output is 2. Oh, output needs to be 1. Oh, wait. I see. Look right here. All right, so we found a problem already. I know, Torva. Whoops. All right, so how do we change the output? How do we do that? Is it right here in the linear? Number of classes. That's what it is. All right, number of classes. Where did we specify that at? Is there a default? How does it know? Model config. Okay, so model config right here. Oh, 2. Number of outputs. This has to go to... How do we specify the number of inputs? I guess we just... All right, so here's number of outputs. There we go. So this is why. All right, here, 1 second. Now we should get that. All right, cargo 1. That's not what I want. All right, that's not what I want. 1 second, you guys. 1 second. Gotta put that thing over here. I gotta press... All right. So this is what I want, but it tells me no. It's telling me no right now. This library has a lot of generics. But yeah, I know, right? That makes it way harder for the average Python code. So many generics. They're like generics everywhere. They're all over the place. All these capital single letters. So many generics, you guys. Fun to have. Nevok Python is recently moving and introducing more and more type, especially after 3. It is, right? Python is getting more type oriented. It is. And there's generics. I think the right because you passed 2 somewhere. Yeah, I did. I passed 2 right here because I want this to be the input, right? It's going to be two features, 1 label. 2 features, 1 label. We're going to try to make this as simple as possible. We'll do number of features 2, number of classes 1, number of hidden units 128. See, here's the deal though. Can this work? Will this work? Oh yeah, because this is an init here. Okay. All right, we're starting to figure it out. Do any of them lean towards overfitting? Yeah, they do. So I think Adam W. I've seen, or what is it? There's another one. I'm trying to remember. The SGD tends to not overfit as much because it keeps things smooth. Autograd will also do a good job, though you can overfit on Autograd as well. You just need to get the right combinations of data. So you want to stop training early, and then test along the way. Run it through another epoch, test it again, run it through another epoch, test again, and you can really, really get like an optimized model. Like you can really optimize the model. Linear 1 should use num inputs. Excellent. You're right. We got it. We like Rust over here. And we're starting to get okay with it. We've used Rust for many years. Don't get me wrong. It's just that using the burn library in AI with Rust is a whole new game. You have to learn everything. You got to learn over from the very beginning. Okay. So that's basically what we're doing. All right. So we got our model. We're initializing it back end. We got a default device, which is probably going to be CPU. We're probably going to want a to-do item here. So see, I'm like throwing in Python comments now. Because I've been using Python. Sorry. We want to do get GPU device. That's what we want to do. Expected 1, found 2. All right. So linear side. Where did it want that? On the linear 3. Linear 3 here. Okay. Got it. Linear 3. For training, we're doing just it. You could do this all on CPU. You do not need a GPU for this. We're doing very small data. We will be doing stock quote data. What is the model supposed to learn? Price predictions, stock market predictions. That's what we're going to do because that's a lot of fun. It's easy. The reason why I like it is because there's a lot of data. Also, it's a little bit of exciting, right? Isn't it a little bit exciting? If you have any questions, let me know, you guys. We're going to make it work. So we're getting started with some... so we've got our metal backend, so it looks like that works. And then we've got our backend here. My backend type, my backend is going to be here. So this is going to be metal backend. Here we go. Right, there we go. Dot. Done. Save. All right. So we get that going. All right. So that just helps me understand how the burn library is working. All right. We're going to run it through and we're going to see what it looks like. Model.forward, tensor.data x. Let out equals. See if that works. Let's see if we can make that work. Let's see if that works. You're trying. All right. So it doesn't like that. Tensor. Oh, so we need to. How do we convert it to a tensor? Let's learn. Let's go to the docs. So I would like to just. So I've got my model here. I would like to just run a forward on it, right? So I've already got the forward here, right? Model backend. Here's the model. We've implemented forward. I just want to run that function. Let's see. Let's just try X. Let's see here, X. Let's see if that works. See if that works. Expected a tensor. All right, so we need to burn tensor. We need to create a tensor out of this. All right, so we need to convert X into a tensor. That's metal backend to from data, the data X, which is X. Okay. So let's do inputs. Let's do input. Let's say input. All right. Let's see if that works. Is that going to be good? Nope. Nothing like it. Try into just like X into. Okay. We'll do that. I'm not using WGPU. Add and device as an input. Okay, we'll do it. We'll do it. Device. Okay. So we want to add that right. Oh, right here. Somewhere here. Like array comma device. Okay. There we go. All right, there we go. There we go. Let me see here. All right, we'll just bring that down there so it's easy to read. All right, there we go. So that might do the trick, is what you're saying? We'll try it out. We're a step close. Wait, are we a step closer? No, we're farther off now. We're way out of there. It doesn't like that. Into must be a known at this point. Okay. Well, there we go. Basically, it needs to know where to put the thing. Yeah, that makes sense. So if we've got the data and we've got the tensor class, and the tensor class is going to need to know where is it going to put the memory. Is it going to put it on the GPU or is it into system RAM? My into suggestion was bad. All right, no worries. Into. All right. Let's try that. Oh, hey, it's building. Hey, there we go. Oh, so that was explicit data from. All right. There we go. All right. I'm actually feeling pretty good now. I'm feeling pretty good now. All right. So let's do print out. Here we go. We don't need this anymore. All right. We're getting good now. We're doing good. Hey, this is great. We have 5 minutes. Hey, Torben. Oh, it's working. It looks like it is. It looks like it. Oh, look at that. All right, something happened. All right, so what do we got here? All right, so this is a tensor. We've got the data, the inputs. Okay, so that was 100%. Perfect. All right, this is perfect. 4 to 1, right? So it's a batch size of 4. The input size it should be like 421 basically is what it needs to be, at least for now. Let's go. All right, Neovec, thank you for your help. This is amazing. I appreciate your time here. Let's go. Let's do this. This is great. All right, feeling a little bit better now. We got something that I'm familiar with, right? Getting a little bit familiar. Like we've defined the model when we shove data into it and we expect data out, right? Some data in and expect data out. All right, so can we do a slice? I want to do a slice. Let's see. Let's do a slice. Let's do, instead of input, right? So I want to only do part of the input, just a smidge. We will be doing more Rust and the burn framework tomorrow. It would be great to get the model to train on the input and output data. That would be really nice. I would very much like that. And then we need to get the download stock data, and then we'll see if we can train the model to learn the stock data.